Hello, everyone. Let's take a look at this LeetCode problem, maximum building height. It's the last question in the weekly context, and it's a hard problem. Let's take a look at how to solve this problem. The problem is the description is pretty long, so if you haven't read the description, you can read it. Basically, we want to build a new buildings in a city. The new buildings will be built in a line and are labeled from 1 to n. There are some rules. For example, the height of each building must be a non-negative integer. The height of the first building must be 0, and the height difference between any two adjacent buildings cannot exceed 1. Additionally, there are city restrictions on the maximum height of specific buildings. These restrictions are given as a two-dimensional integer array restrictions, where restriction I is an ID and maximum height indicates that building ID must have a height less than or equal to maximum height. It's guaranteed that each building will appear at most once in restrictions, and building 1 will not be in restrictions. So we need to return the maximum possible height of the tallest building. For example, n is 10, so we need to build 10 new buildings. And we know the first building is 0, the height is 0. And we have these restrictions. For example, for the building 10, the maximum height is 3. So if we don't have these restrictions, we know the building height can be taller. Okay, so our task is to find the tallest building given these restrictions. Okay, so the first question coming to our mind is, can we get the highest building in those restrictions point? For example, in point 5 to 7, 10. Can I know what's the highest building in this position? Okay, let's take a look at one simple example. If we only have one restriction to 1, we know the height of 2 must be at most 1, right? So the height of 2 is 1. The tallest building, the highest building at point 2 is 1. What if we have another restriction at 9? What's the highest building can we put in point 8? We know it's 7 since 9 is useless here. 2 is 1, then 3 is 2, point 4 is 3, so point 8 is 7. Okay, now let's change the restrictions from 9 to 2. And let's add another restriction, 6, 11. So the question is, what's the highest building can we build on 6? Is it 11? Of course not. Let's take a look at the left neighbor of 6, 2. 2 is 1, so 3 is 2, which means for 6, it should be 5, right? Is it 5? No. Let's take a look at the right neighbor, which is 8. 8 is 2, so we know in 7, 3 is tallest. So in 6, 4 is tallest. So it will become 4. So to determine the tallest building on a restriction point, we need to take a look at the left point and take a look at the right point. So we can build code like this. To make our coding easier, we push 1, 0 and n minus 1 to our restrictions, and then we just sort them. Since these points are not unsorted at first. So we have this first for loop. So we just iterate from left to right to update our restrictions based on the previous restriction. Then we iterate from right to left. So we get the maximum height of building 6. Okay, after this for loop, we get the highest for each restriction point. Now we just need to for loop each of them to get the highest building between these restriction points. Okay. For example, we have restriction point X and Y, and for their highest building, which is 4. So what's the highest building can we build between X and Y? It's very simple. the answer is 4 plus y minus x divided by 2. Since we need to like go up, then go down. Okay, what if the height is not same? It's also very simple. Since for x, we can just go one step further to make it like we have x plus 1, 4. Then we can use the previous algorithm. Height is 4 plus y minus like x minus 1, then divided by 2. Okay, so we have a result. Like for each iteration, we just calculate the highest building between these two like restriction points. Then we update our results. Finally, we just return this result. Okay, so time complexity is very obvious since we have a sort here. So if n is let's say k is the size of restrictions, then our algorithm time complexity is like k log k. Okay, that's it. Thanks so much.